Alright, so we're going to talk about solution stoichiometry. Again, make sure you guys have the warm-up copied down, but let's move on. So, we talked about stoichiometry before. It's basically, I give you chemicals, and you figure out how much of a chemical you can make. Solution stoichiometry, the steps are a little bit different for the math, so I'm going to give you guys a couple minutes to copy down the steps. Okay, because it's not the same thing. Before, we just did the 3 fractions, and then we solved it, but this time we have to use the molarity equation, so we're going to be doing something a little bit different. So just make sure you guys copy down those 4 steps, and then we will go over how to solve a problem in just a second. Alright, so for solution stoichiometry, the first thing we want to do is same thing as regular stoichiometry. We want to start by balancing the equation. Now, I know it's been a while since we did that, so if you want to try it, you can try it on your own, but I'm going to go over how to do that. So, for balancing, first thing you want to do is you want to copy down the equation, obviously. And then after that, we are going to write a table. Now, before we make the table, I want to kind of point out these things right here because this stuff is new, right? Do you guys see these parentheses with the little letters next to it? These right here are going to be helpful in the lab that we have coming up. These basically tell you the state of matter of these chemicals. So state of matter is whether it's a solid, liquid, or gas. So if you look at Ca, do you guys see how there's a parentheses and an S? This is telling us that this calcium is just a solid form. So you have solid calcium. So whether it's like a chunk or powder, this is just a solid. Okay, so if you ever see a chemical with the parentheses, little s next to it, that's a solid. Okay, the next one, AQ, this stands for aqueous, which means that it is dissolved in water. So this chemical, the chemicals that have AQ next to it means that it is dissolved in water. Okay, and then the last one that we see right here is parentheses G, and that's telling you that it is a gas. Okay, and so H2 gas is being produced. And this is going to be helpful when we do our labs because now we're going to have different chemicals in different states of matter. Some are solid, some are dissolved in water, some are gases, and these labels allow us to figure out what these chemicals look like when we're doing the labs. Okay. Alright, so with that being said, let's balance our equation. If you guys remember, the first thing we want to do is first we want to make a table where we count up the elements that are in our equation. So we're going to look for the capital letters. If you guys take a look at this equation, we have Ca, calcium, we have H, hydrogen, and we have Cl, which is chlorine. And the first thing that we want to do is we want to count how many we got on the left side versus the right side. So I'll give you guys a second to copy down the table and see if you guys can count up how many of each you have on the left side and the right side, and then we'll go over that in a second. Alright, so hopefully the counting was pretty easy. You got 1 of each on the left side because you got the elements but no numbers. On the right side, you have 1 calcium, you have 2 chlorines because there's a 2 behind it, and you have 2 hydrogens. Okay. Everybody good with the counting? Hopefully that's not too bad. Okay, so we're going to look for the ones that are not balanced out, and you guys should see that it's going to be hydrogen and chlorine, and we need more on the left side for both of them. So we have to add H and Cl to the left side. Luckily, we have a molecule that has H and Cl, so we're going to add HCl. Now we have 2, and we have 2, and we're all balanced. So I'll try to keep the balancing a little bit easy for this unit because that's not the main focus of this unit, but that's pretty much the gist of it, yeah. Yeah. So if you take a look, after we counted the elements, you're going to notice that we need more on the left side for H and Cl, right? Because there's 2 and 2, 1 and 1. So we have to add H and Cl. So we look for the molecule that has H or Cl, and we see this guy right here. We have to add what's already there. So we're going to copy down. Yeah, we want everything to be equal to one another, balanced out. Yeah, so we add the chemical that has H and Cl, and now you have 2 H's, right? So this gets to 2, which is equal to that, and you have 2 Cl's. So this is at 2. And now you have 2 and 2. Alright, so to finish balancing, we just put numbers in front of the blanks. You put a 1 right here if you didn't touch it. Now there's 2 HCl, so we put a 2 there. And then we put a 1 here and a 1 here. And we're done with step 1. That's balancing the equation. Any questions on the balancing? Good with that? Okay, and if you guys need a review again, I think the stuff is still on Canvas if you want to go back and just watch the lecture just on balancing. All right, let's go to step 2 now. So let me just erase this stuff. And if you miss something, don't freak out too much. Again, I'm recording the lecture, so you guys can always go back and copy things down. Okay, so step 2. What we want to do is we want to find our starting and ending chemical, and we're going to ignore anything that's excess. So for this one, we need to read the problem. So the starting chemical is the chemical that you get your numbers for. So I want you guys to read the problem. And on your paper somewhere, I just want you guys to write start. And I want you guys to write the formula for the chemical that you have all the numbers for. Okay? And then after that, I want you guys to find the ending chemical. This is the one that it's asking you to find. So see if you guys can figure that out by reading the problem. I want you guys to read the problem and identify your starting and ending chemical. Okay, so you're going to be reading the problem. So try that out. All right, guys, so let's take a look at the problem. So it says, suppose that 100 mils of 0.5 molarity HCl solution. So if you look at all the numbers, what chemical are all the numbers associated with? Yeah, HCl. So we're going to write our starting chemical is HCl. All right, and then it says it reacts with excess Ca, calcium. So remember, if it's excess, you can ignore it. So if you want, you guys can cross out calcium, because we're not going to be using that at all. So we can cross it out just so that we can ignore it, don't get confused. And then the question is asking how many grams of CaCl2 will be produced, which means that what we are looking for in this problem is going to be CaCl2. Again, it's usually going to come after the question how many or something like that. So CaCl2 is what we are looking for. Okay? Which means that H2 is also not important. Okay, everybody good with that? Okay, that is step 2. Okay, now we can start the actual math component, and the first step is pretty much what we've been doing this unit. Okay, step 3, you want to use molarity to find the moles of your starting chemical. So we're going to write down the molarity formula. So molarity is moles over liters. And I'm going to give you guys about a minute or two. See if you guys can use the numbers in the problem to calculate for moles of your starting chemical. Okay, so you're going to use the molarity formula right here. See if you guys can figure out, using the molarity formula, the moles of your starting chemical. All right, guys, so you're going to plug in the numbers in the problem to the molarity equation. It's what we did in the warm-up and we did last week as well. For molarity, you should see that as 0.5 molarity, so I plugged in 0.5. You have 100 milliliters, so if you divide that by 1,000, that'll give you 0.1 liters. And then you just multiply the two together, and that gives you 0.05 moles of HCl. Okay. Everybody got that? Any questions? All right, so that is step 3. It's just using molarity. All right, so step 4 is going to be our new thing, the one that, the stoichiometry portion. Now, before we did stoichiometry with 3 fractions. Luckily, for this part, we only need to do 2 fractions. Okay, so I'm going to show you guys what the 2 fractions are. So I'm going to, let's take our number right here, and let's start it as our Stoich problem. So we're going to write 0.05 moles of HCl, and we are going to set up 2 fractions. All right, so this first fraction right here, on the top you're going to have moles, bottom you're going to have moles, and then the last fraction, on the bottom you're going to have moles, and on the top you're going to have grams. Okay. Okay, and I'm going to color code as we go along so that you guys know the starting versus the ending. All the starting stuff, I'm going to label it red, and all the ending stuff, I'm going to label it blue. So as we do different problems, same thing, red will, or you can just put the starting chemical in the positions with red and the ending chemical in the positions with blue. Okay, so the starting number is obviously our starting chemical. And then on this fraction right here, the first fraction, we are going to get the numbers for this from the balanced equation. Okay? And on the bottom, you are going to put your starting chemical, HCl. And on the top, you're going to put your ending chemical, CaCl2. Okay, so the bottom of the first fraction is your starting, and the top is your ending. Okay. So this should ring a bell from regular stoichiometry. If you guys remember, these are the last two fractions of regular stoichiometry. We're just skipping that first fraction. All right, so we're going to look at the balanced equation and just look for the numbers that are in front of these chemicals. So if you guys take a look at CaCl2, what number is in front of CaCl2? 1, yeah, sorry, wrong chemical, yeah. CaCl2 has a 1, so we put a 1 on the top next to CaCl2. And HCl has a 2, so we put a 2 on the bottom. So 1 goes on top, 2 goes on bottom, because we're going to get the numbers from the balanced equation. Okay, and we're halfway done. Yeah, molar mass. Okay, and then for the last fraction, you are going to find the molar mass, and this is going to be always of your ending chemical. Okay, so CaCl2. So this one, like we've been doing, you're going to pull out your periodic table, find the molar mass of CaCl2, and then you're going to plug it in. And after that, if you feel comfortable solving all the way, go ahead, but at least try to find the molar mass of CaCl2 using your periodic table. Give you guys a couple minutes to do that. Alrighty, guys. So for the molar mass, you guys should have gotten 110.98. Everybody good with that? Okay, 110.98. You're going to add up Ca and chlorine 2 times. That's 110.98. And the number that you add up from the periodic table always goes next to G. And molar mass is always 1, so we put a 1 on the bottom. Okay. I'm going to show you guys how to plug it into your calculator now. So again, always go from left to right. It just makes it a lot easier, okay? So we're going to take our first number, 0.05. We're going to go left to right. As we go to the right, we can ignore the 1s because if you multiply by 1, it's the same number. There's a 2 on the bottom, so we're going to divide it by 2. And then there's a 110.98 on the top, so we're going to multiply by 110.98. And that's pretty much it. We can ignore the 1s because if you multiply or divide by 1, it doesn't change your number. So we're going to get 0.05 divided by 2 times 110.98. And so our final answer is going to be 2.77. And we're going to label our number grams of CaCl2. And that is our final answer for this problem. Okay, and that's solution stoichiometry. I know that we took our time going through all the steps very slowly, but when you guys do your actual problems, as long as you show me your molarity calculations and your stoich, then I'll take that as your as credit. Okay, so just make sure you show me your calculations. Yeah, what's up? Yeah, you don't need to write the steps like step 2 especially because just identifying the start and ending. If you can do that in your head, that's totally fine. Yeah, great question. All right, so just to kind of help you guys visualize what's going on, I want you guys to draw this on your paper. But this problem is basically telling you that, hey, if you have Ca, so you have solid Ca, and if you combine that with a solution, okay, that is 100 milliliters and 0.5 molarity HCl. So if you mix these two things together, you are going to make 2.77 grams of CaCl2 that's inside of a solution. That's pretty much what all this math is telling us. If you mix these two things together, you're going to make 2.77 grams of CaCl2, and since it's AQ, it's going to be dissolved in water. And this is what you'll be doing in your lab. I'm going to have you guys mix solutions together, and you're going to be drying it out to figure out how much of a different chemical you made through that mixing.